Thank you, everyone. This is Team Green Fertilizer Standalone On-Demand Production System. My name is Bernard, and the other two team members are Sam and Visal. So why is this system? I come from Uganda. It's a small country of 93,000 square mile, and the current population is 47 million. It is estimated to go over 100 million in 2060. I remember one time when I went to the hospital to check on my knees, and I found over 100 children hospitalized because of malnourishment. And in 2019, United Nations stated that over 41% of the population are malnourished, and that tantamount to 18 million people. And out of that, 3 million are actually children. So we have farmers, but this farmer encounters very low crop yield because the fertilizers are very expensive and also difficult to get. So we propose in our solution to design a system which is able to produce fertilizer from air and water using solar and plasma on site. And the schematic of the system is shown on the left-hand side. We have the sun, which provides the energy, and this energy is converted into electrical energy by solar modules. And the electrical energy is converted into plasma. The plasma interact with air and water to generate the fertilizer. The benefit of this system is it increased crop yield, and of course, it would increase revenue, and we expect the standard of living also to improve. And secondly, it is cheap in the sense that the production is done locally in the garden, no transportation cost, and it is easy to maintain, and we expect it would reduce emission of greenhouse gases. Currently, we have already one prototype we are testing in the University of Massachusetts. The estimated production rate of the system is 4 grams per liter per minute and operating time of 5 hours. I hand you over to Sam.
Thank you, Bernard. So the market opportunity here is that there's over 2 million farms in Uganda. So we're planning to market to farmers in Uganda, and there's almost 600 million farms worldwide. The Uganda population is expected to increase, and as well as the opportunity comes from the high cost of fertilizer compared to the rest of the world. So that leads to our system being cost effective. And there's abundant solar energy available for about 8 hours a day in Uganda. So there's a few competitors in the space, one of which is in the US, GreenPath Industries, followed by a couple other competitors around the world. And our system is different. So the difference is that our system is primarily the plasma is generated by solar power, which is a renewable energy resource, and it reduces fossil fuel emissions. And our system also is on site, which relates to the system being able to produce fertilizer in a timely manner and to reduce transportation costs as well as emission results. And I'll hand it over to Visal.
Thank you, Sam. So we divided our project sustainability into 3 phases. The first one is regarding the demonstration phase, which we will develop the prototype and we have it installed and test its feasibility. After we done all of that, then we establish what we call demonstration size, and we provide technical support to the farmers and to the targeted community that we plan to install. And we will develop the technician network that will help to maintain the system along the way. And finally, we will do the financial analysis. It's kind of how we, we do the financial plan for our project, like the system cost, simple payback period, how it save the fertilizer or increasing the food production, etc. Next, please. Yeah, so regarding our resources, right now we already have, one prototype funded by our sponsor, which we already installed in the lab in University of Massachusetts Lowell. So the next step is to, plan for another 2 prototypes for testing and then bring it to Uganda for development. So through your support, we can make it possible, and we will make it possible. So please join us to make a difference in people's life who need it the most. Thank you very much.